Okay, here we are, continuing our saga with patient number 2. And just to recap here what I have done, and we have okay, let's see here. You can see here I have lifted the diodes right here and installed a resistor there to soften the clipping. So now we have softened diode clipping. And it's a low value resistor. You can only use so much there before it starts, the guitar tone really starts coming through. So just to make, you can only add a little more organic tone into the clipping with that resistor. And we have here the Chinese polyester 1 end cap. And on the back we have another Chinese 2 end cap for the bypass on the input. These made a small difference. So we're working in little steps here in gains of improving the tone. I'm not quite sure what I'm going to do with sound clips on this because I've been recording it straight into a digital recorder, and it sounds awful harsh and trebly without having a tone stack, and the attenuation, frequency attenuation on the low end and the high end of the cabinet. So I've designed some cabinet simulators and a tone stack in a box that I can use with recording these things directly. So my next idea here is, it's still kind of trebly, so I'm going to add a bypass capacitor somewhere in here, probably over here on the output stage. I'll add a bypass on the collector resistor of the output stage. That'll take high frequencies out from everything that passes through the pedal. And I put this on the scope with a signal going into it, and it ran through each of the sections, and I found the input section here clips with about 300 millivolts input signal, and that's easily a good strum. On my PAF humbuckers, I scope them and I get about 2 volt peak, attack peak on a strum. So this input stage, that transistor right there, actually it's a pair of transistors, that one and this one, form a feedback amplifier. Pretty similar to a fuzz face. And it's clipping with only 300 millivolts signal. I'll have to go out and run a simulation of that to see if I can improve it. On my breadboard I improved it a little bit by changing one of the emitter resistors. And then I checked what happens when the signal goes through the phase splitter, which is this transistor, beneath that red wire, orange wire. And this is one of the parts of the circuit that I found was rather poorly designed. The phase inverter is not biased very well, and it clips on the bottom half. So I'll need to check the voltages, and I might rebias that. The octave engine seems to be working pretty good on this one. It's a little off, and I could probably change one of the, since there's no holes to add a trim pot, I can probably change one of the bias resistors here to 22Ks and get it to balance a little better. It's got some octave. Might add a little bit more. Might try adding a little bit more and see if it makes any difference. So that's about it. Slow progress. Alrighty, and we'll see you for the next part. Thanks for watching. Onward.